first topic of discussion is to compute circular convolution using linear convolution. But before computing circular convolution using linear convolution, let us understand how to compute linear convolution. So that is why I have taken two sequences x1n and x2n. Each contains 4 number of samples. Now I am going to use the tabular method to calculate linear convolution between these two discrete time sequences. So first of all, I have written x1n samples in horizontal fashion and x2n samples in vertical fashion. Now next, I am going to multiply these samples in a row and in a column. So 1 multiplied by 1 is 1. Now the first element in the first column is getting multiplied with the second element in the first element in the second row. So 2 multiplied by 1 is 2. Then 1 multiplied by 3 is 3. And 1 multiplied by 4 is 4. Now let us calculate another element in the second column. So the 1 multiplied by 1 is again 1. So the same multiplication we will get. Now let us calculate the third column. So the 2 multiplied by 1 is 2. 2 multiplied by 2 is 4. 2 multiplied by 3 is 6. And 2 multiplied by 4 is 8. Now in this fashion I am going to complete the last column also. Now I am going to combine the multiplications and going to sum up the samples. So that for that purpose I am going to make the draw the diagonals and I am going to gather the samples. So this is how I am drawing the diagonals, and now let us compute the output. Now if you see the first section, there is only one element, so the output is only 1. Now if you see the second section, there are 2 elements. Now if you see the formula of linear convolution, there is summation sign in the formula. So you have to compute summation of the output samples. So 2 plus 1, it will be 3. Now if you see the third section, it will be 3 plus 2 plus 2. So I will get 7. Then the next sample in the output will be, I have to sum up all these outputs. So 4 plus 3 plus 4 plus 2. So I will get 13. In this fashion, I am going to complete the summation of all the output samples. So what is the output of the linear convolution? It is 1, 3, 7, 13, 14, 14, 8. Now how many number of samples linear convolution output contains? If you see, the input sample x1n contains 4 number of samples. Another input sequence, it contains 4 number of samples. So the output will contain 4 plus 4 minus 1. That is 7 number of samples the output sequence will contain. Now let us compute circular convolution between the same sequences. So for computing circular convolution, I am going to use matrix method. Now to compute circular convolution using matrix method, if you see this formula and the LHS of this equation, there is a y vector, that is the output vector, which contains y0 to y3. That means 4 number of samples. Now input sequences contain 4 number of samples. So output sequence also contains 4 number of samples if you compute the circular convolution. Now for matrix method, I have taken one sequence 1, 2, 3, 4. I have written it vertically, which is x2n, and another sequence x1n, its vector I have written, that is in the matrix form I have written 1, 1, 2, 2. Now how to complete this matrix? This matrix is n by n matrix. That means right now it will be 4 by 4 matrix. So how to form this matrix? So first of all, I have written 1, 2, 3, 4. Then the last element of the first column becomes the first element of the second column. And the other elements are diagonally shifted. So the second element of the second column becomes that is the first element of the first column. Then this 2 will come over here and this 3 will come over here. Okay. Now this 3 will become the first element of the third column. Then again this 4, that is the first element of the second column, will become the second element in the third column. Again this 1 will be the third element in the third column and this 2 will be the fourth element in the third column. Now this 2 will become the first element. So this is how I have completed this 4 by 4 matrix, and then I have done the matrix multiplication. So I will get the answer 15, 17, 15, 13. So the circular convolution output is, it contains 4 samples, but we have seen that the linear convolution output contains 7 samples. Now we are going to compute linear convolution using circular convolution. So for this again I have taken the same sequences and now I am going to compute the linear convolution. So first question is, can I get linear convolution output using circular convolution? Length of both the sequences is 4. Circular convolution output length we have seen that it is 4. How many samples linear convolution output contains? It is 7. That is also we have seen. We have computed linear convolution. That time we have seen that the output contains 7 number of samples. Hence, therefore, because I want to compute linear convolution, I am going to make the length of both the sequences 7. So right now the length is 4. So I am going to add 3 zeros to both the sequences. So already sequences have 4 samples. So append 3 more zeros to both the sequences. So now I have appended 3 zeros to x1n and x2n. And now I am going to compute circular convolution. Again I am going to use matrix method to compute circular convolution. So the output, that is vector, that is y0 to y6 element, that means it contains 7 number of samples, and one sequence, input sequence, that is 1 1 2 2, that means x1n I have written vertically, and this is 7 number of samples. So I have completed this 7 by 7 matrix in the same fashion, uh, the way I have explained you earlier, that the last element becomes the first element of the second column and then shift all the elements and complete this matrix. Then the second matrix is x2n, that is x2n vector I have written over here 1 2 3 4 0 0 0 0. Now let us multiply these two matrices. So I will get the answer 1 3 7 13 14 14 8. Is the answer same as linear convolution? Yes. Now we have obtained linear convolution using circular convolution. Now this is a block diagram of computing linear convolution using circular convolution. So if you see that there are two sequences which are inputted, which is x of n and h of n. X of n is having length L and h of n is having length M. In our previous example, both the sequences were of same length. But now in this block diagram, we are drawing this for generalized conditions. So that is why we have taken the different lengths. Now how to make the lengths equal? So for that purpose, x of n is appended with m minus 1 zeros and h of n is appended with l minus 1 zero, so that both the sequences will have the length l plus m minus 1. And then take the circular convolution between these two sequences so that you will get y of n, which is also having the length l plus m minus 1. Conclusion is linear convolution can be computed using circular convolution. Now there is one more method of computing linear convolution with DFT and IDFT. So again, I have taken x of n and h of n of unequal lengths. So that is why I have appended zeros to make both the sequences of the equal length L plus m minus 1. And then I have taken the n point DFT of x of n so that I will get x of k. Again, n point DFT of h of n, so I will get h of k. And then I have multiplied these two DFTs, and so the multiplication DFT will be y of k, and then again take the n point inverse DFT of y of k to get y of n. So y of n will have the length L plus m minus 1. Conclusion is linear convolution can be computed using DFT and IDFT. So now let us compute the linear convolution using DFT-IDFT method using the same sequences. So again I am considering the same sequences, and now length of both the sequences is 4. We want the length of the output 7. So that is why I am going to find out the DFT. For finding out the DFT of x1k and x2k, we need a twiddle factor matrix, that is W8 matrix we will need. So I am going to append 4 zeros. So I have appended 4 zeros, and now this is W8 matrix. And what is the formula for computing DFT? It is x of k is equal to W8 into x vector, that is the input sequence. So now in this equation I have multiplied this W8 matrix with this input vector, which is x1 n, and the matrix multiplication is done. But the computations now in similar fashion, we have to compute x2k, and then x1k and x2k we have to multiply, and again we have to take the inverse of that to get the linear convolution output. But we see that the computations are very complex, and we will implement a MATLAB program for this example and we verify that the output is same as linear convolution output. So the conclusion is linear convolution can be computed using DFT and IDFT. Another conclusion is linear convolution can be computed using circular convolution. Now from the first conclusion, the calculations are carried out in frequency domain, and for the second conclusion, calculations are carried out in time domain. Now basically why this linear convolution calculation is required? Because linear filtering operation is implemented with the help of linear convolution. So this is the application of linear convolution.